Hey, what's up guys, Bigstuff3 here. So on today's video, we're going to be going over the ignitions settings section. We've already got previous videos made on the AFR startup fuel and system. This is going to be our next video that we have here for the ignition settings section. So why is the ignition settings section important? Well, obviously without spark, this engine is not going to do anything. So inside this section is where you're going to find your spark tables as well as any additional spark modifiers we want to put on the ECU as well as far as timing control. So let's get into it here. The first thing that you're going to notice here is that there are two spark tables in this configuration, okay? So depending on how over here in the system section you have the FSL configuration set for, you're going to have a certain number of actual maps available for you in that section. So in this particular application, this is an alcohol-based setup. We've got two sets of injectors, and we're doing a stage setup to where at 25% duty cycle, we're going to switch from 8 to 16 fuel injectors. When we switch from 8 to 16 fuel injectors, we're actually going to ride another map. So there's going to be a spark table 2, an AFR table 2, and a fuel settings table 2, okay? If I was to go and just simply have our standard actual BCP setup, okay, which is a base map, if you would, I'm only going to have one map inside there because I'm only going to be rewriting on one map. Now, you do have the ability to make multiple maps. So if I increase this to table number 2, now I'm going to have spark table number 2, AFR table number 2, and fuel table number 2. All right, so it just depends on how you've got everything set up here in the FSL. If I went gear over RPM, and I actually had 4 gears I was working with, you're going to have 4 different spark tables to choose from, 4 different AFR tables to choose from, 4 different fuel tables. So all depends on how you've got everything configured. So we'll go back to the stage setup right now. The stage setup is, again, 16 injectors. We turn on to the second set, and we're going to fire off onto the other table, okay? So let's actually show you how that works. If I was to come over here in this graphing and logging section here, I'm going to slide this over to the right, and we'll show you basically just something that we can use to actually work with that when that FSL actually turns on. I'm just going to load up here basically a default tab of a data log. And let's bring something up here, okay? So if I go into my default tab here, what I'll do is I'll go into a tab that doesn't have that much stuff on, and it'll make it easier to see. Okay, we'll just go to Translib. So if I come over here to FSL, sorry, my computer's wigging out here, FSL table index 2, right over here, okay, this purple line that turns on right there, that is the second set of injectors turning on based on duty cycle, okay? So when this guy turns on right there, we turn on our second set of injectors, okay? And you'll see here that if I'm on FSL table index 1 up here in purple, and then as soon as I come up here, FSL table index 2, that's the exact point that we actually switch to the actual second map, okay? That's how that works. So configure your FSL section however you're going to want to run it, and then that way you'll get to configure all your other maps, including the ignition section, okay? So let me go back to our base table here. And if I go back to my ignition settings, first thing you want to do is on your spark table here is go and configure your spark table for how you're actually going to run it. So what I mean by that is configure your axes for load. In this case, I've got a 5-bar map sensor on this guy. I got 55 pounds as my top row for boost, 10 inches as my lower row, and then I'm 750 RPM to 9,500 RPM. Now, there's another video covering how to do all these tables and configure everything. But if you simply hit this arrow down here, it'll pop out another window where you can actually go through and reconfigure all these axes here, okay? So typically what I'll do is, for obviously a race car application, we don't care much about vacuum, but we care more about boost. We want a lot more resolution there. So you would just simply go from 0 to 55 pounds. You would highlight the row, right click, and then interpolate the selected cell values. Then just to make it a little cleaner, I like just putting a .0 at the end instead of having the .2, .8, whatever they typically may come up with when you interpolate. It's the same thing for the RPM. If you just want to make a nice linear line from 7500 to 9550, you can right click, interpolate. Okay, it'll interpolate from 750 to 9500. Then you would apply the new XY values and interpolate Z. Okay, so that's how you reconfigure those tables as far as the X and Y axis for each line. Okay, obviously Spark data is going to be completely dependent on the combination that you're running, so you're going to have to figure that out for what you want to run. If you have any questions, you can definitely email us, give us a call. We'll be happy to help you out with some base Spark numbers there. Okay, so Spark Advanced tables, again, just don't forget, depending on how the FSL is running, you're going to have two tables. Obviously for Spark Table 2, this is the one that we're using going down track. Now, this tune-up is not plugged in this way, but you could always, if you want to have more resolution, have this table go from, let's say, 2,000 RPM instead of 750, and maybe 4 pounds of boost instead of 10 inches of vacuum as the lowest points. That way you can actually get some more resolution. So when you switch on the duty cycle, you're nowhere near that low RPM and nowhere near that low of boost or engine vacuum. So you can increase the resolution if you want as well too. That's why you have the adjustability there on the X and Y columns. Okay, so going back up here, the Spark modifier selections is where we're going to actually put some modifiers on our Spark tables, if you would. So the first one you're going to see here is this test timing enable. So if I enable that, in this case I've got 20 degrees. This is for when you're first setting up your ECU and you want to dial in your actual engine timing. You're going to have this number here of 20, and you can make this 20, you can make it 30, it doesn't matter. And you're going to want to rev the engine up to around 2,500, 3,000 RPM. And then if you want to adjust it on your crank trigger, distributor, however you're actually running it, you can do it there. If you have a coil on plug application, again, depending on how you want to set it mechanically, you can do it that way. If you do want to change it, you have a crank reference offset adjustment in here. You can vary this number as well to also dial in your timing, okay? But that first box is just simply to enable test timing. Now, if you do go over, I believe, 4,000 RPM, this will kick out, because obviously you're making way too much RPM at that point. It's going to default back to whatever you have in your Spark map. But just don't forget to turn it off. You know, that way when you're done, you disable it, and then you're back to writing on your actual Spark map. Okay. Next one is a 2 to 3 step coil unplugged dwell reduction. If I do enable this here, I'm going to provide 2 milliseconds of dwell reduction whenever I'm on the 2-step or the 3-step in a coil unplug application. So in my ignition settings section here, I have a dwell time table. This dwell time table is configured obviously as I'm making more boost in RPM, I'm going to provide some more dwell. As I'm making more RPM and battery voltage, the dwell is going to go down a little bit. So most 16-volt applications are somewhere in this row right here. So we're going to increase the dwell a little bit as we're obviously increasing with engine RPM. So if you're on the 2 or 3-step chip and you're somewhere around here, it's going to knock 2 milliseconds of dwell off of these charging times in the table. You typically will use this if it's just hitting really hard on the 2 or 3-step. And don't forget, the 2-step in our world is like a boost builder application or burnout RPM. The 3-step is what we use for a trans brake, for a clutch. That's our launch leave RPM, is the 3-step. Okay, so this will knock the dwell out of there if you do not want, if you have it set a little too high, you feel, on the actual rev limiters. Okay, so we'll shut that down and we'll disable this. Idle spark's pretty self-explanatory. Whenever we are in the idle mode, we're going to have an idle spark curve here. So this one, for example, if I got nothing here, okay, basically I'm at 0 degrees of spark trim. I can pull out up to 8.6. I can add up to 9 based on the error from our set point to the actual engine RPM that we have. So this will just basically add or subtract timing based on how far away you are above or below your current RPM target. Now, in order for this actual table to work, though, you have to make sure that your TPS setting is below this max TPS for idle. So in the system operating configuration section, you've got this number here. So wherever you have your TPS sitting, most people will calibrate the TPS, which you can do in the Gen4, and then have it read 0%. And then as long as I'm below 2%, I'm going to be considered in an idle mode, and the idle spark table will work. Once I get above 2, idle spark kicks out. Now I'm just writing on my actual spark table itself. All right. So that's enabled. Intake air temperature spark, again, pretty self-explanatory. When I enable intake air temperature spark, I'm going to go back here to the ignition settings section. I'm going to have an intake air temperature spark trim table, and all I'm simply doing here in this table is, as the intake air temperature gets hotter, I'm just taking some timing out. So we're trying to make sure that we're not going to knock. If the air gets extremely hot, you have a chance of having the fuel air combustion event happen a little sooner. So depending on that, you may want to actually pull some timing out. Vice versa, if it's extremely cold, you may want to actually add some back in. So you can take this table and do what you want with it. It's definitely more of a knock reducer. As the intake air temperature goes up, you're definitely going to want to pull some timing out there, okay? So that's the intake air temperature spark curve. I'm going to disable that. Now you'll see here the E85 spark offset is grayed out. That's because if I come over here to the system section and I go to hardware configuration, this is actually where you tell it what kind of fuel you're running. Well, this application's on methanol. Now, if I was a flex fuel sensor E85, you would see I'd now have the ability to have an E85 spark offset. But because this ECU is not running a flex fuel sensor E85, there's no E85 icon up here. There's no menu to even work from. This won't do anything. But you will know that if you do see anything grayed out in the project, it's simply because either an option's not turned on or it's been disabled somewhere else. So if I can disable this guy and I put it back on methanol, you'll see here that it gets grayed out. I can't even use it. All right. Next one down here we have is a Nos PWM spark retard. So we have a Nos PWM section up here. It is enabled right now, but as you can see below it, I've got these couple areas grayed out here, okay, below the programmable duty cycle section. If I enable this now on the Nos PWM spark retard, you're now going to see it is enabled. So whenever the Nos PWM is activated, there's going to be a table in here, and there's going to be a time and an actual retard here. So at 5 seconds, I'm pulling out up to actual 10 degrees. So this table is only going to be used for the Nos PWM section. If you don't have it, don't worry about it. It does not have to be disabled. If I disable it again, you'll see here it does go away. Okay. Now for the generics here, we have 4 generic curves you can pick from as far as multiple X-axis data sources. This one, for example, has a laser height sensor that we're working with here, but you have a number of X-axes you can choose from here, from RPM, boost, pressures. For this example, we're using laser height. And what we do here is, in the generic section, if it's you see it's titled generic 1D spark curve 1, and you'll see that it's highlighted here, okay? And if I come into it here, as the laser height goes up, we are pulling timing out to help control the front end of this vehicle, okay? Now, what you do see here is all these other ones are disabled, right? So if I come back over to the generic 1D spark curve 1, that's the only one that I've got highlighted. Now, if I highlight the generic 1D spark curve 2 and enable it based off of boost, you will now see that I have it available to use. And again, you can create a spark retard or additive, whatever it is you want to do with this table as well, okay? But one thing to always remember in all these generic curves, whether it's in the AFR section, fuel setting, or spark, because we have them in a bunch of different places here to choose from as far as the generic sections, they all have to be turned on with the generic port editor. So if I wanted to turn on this generic 1D spark curve 2 using boost as the X-axis data source, just because I've turned it on here does not mean it's doing anything, okay? Even though it's here, it's not doing anything. You have to come over here to the system section, to the generic port editor, and you've got to come down into that table, and you got to configure it to tell it when to actually turn on. So you'll see here it's not enabled, right? I have it highlighted, but there's no green little dot next to the generic 1D spark curve 1 that we're using for the laser height sensor. All you simply have to do is click enabled, and my power on value is going to be off. When I go active, I'm going to turn on. So what that means is This output channel is going to be doing the calculation of when I'm going to do something, okay? So when I'm not above 1 pound of boost, okay, my power on value is off. So this condition is going to be off. When I go above 1 pound of boost, I'm going to turn on, and that means that I'm going to turn that table on. So this output channel can be configured for anything. I mean, these are all the data points you have here to choose from. So basically, we give you every data point possible that we have inside the ECU to configure with, to work, and to actually run this data point. Now, you can have up to 4 additional conditions, a bunch of ands and a bunch of ors to configure these tables from. But you have to remember, none of these tables will work correctly unless you have an output channel configured for it. One of the biggest things too is when you're done, you've got to burn it, and in order for the actual ECU to take any change in the generic port editor, you have to reset the ECU. So any changes in the generic port editor have to have an ECU reset. So you burn the change and you cycle the ECU, turn your ignition off, wait about 4 or 5 seconds, turn it back on, and now the active conditions should be set to true, okay? But just make sure that you want a generic curve enabled. You've got to come in here and turn it on in order for it to work correctly, okay? And that's it for the spark modifier selection. Everything else that we've talked about in the ignition settings sections will only be populated based on whatever spark modifiers you have set up. Ignition settings section is very simple. Just make sure though that your timing is accurate. Make sure when your first fiber combination, you definitely do your test timing to make sure your timing is adjusted properly and tracks properly. One more thing is, if you are doing the test timing, if I come over here to system operating configuration and you do rev it up and you do see your time is moving a degree or two, adjust it with either the crank trigger distributor, however it is you're actually doing it, or adjust this offset angle. If your timing's off by a degree or two because of your latency in your system at idle, we don't really care much about that. But what we do care about is when you're revving the engine up high, that we got to make sure the timing is being stable and under control. We want it to settle out then, okay? So you can just change it with this number here, and then that way you're good to go. So if you have any questions, you can hit me up at ben@bigstuff3efi.com or go to the website bigstuff3.com. And thanks for checking out this video, and we'll see you on the next one.